So all of you know how to calculate the viscosity for the liquid slag. So you can simply go to the package and then there's the viscosity module and you open it and you can just simply enter your composition and the temperature and select the prop database. And then if you click the calculate, it will give you the viscosity for each composition of the slag. But this is theoretically only for the molten slag, liquid slag, single phase. But in the many metallurgical process or many pyrometallurgy process, we know that slag sometimes containing some solid phase as well. So then how can you calculate the viscosity when you have slag, which is mixture between the liquid slag and the solid slag together? There's no general rule, but one of the most well-used, most actually the widely used equation to estimate the viscosity for the solid liquid mixture slag is so-called Einstein-Roscoe equation. And so in the key actually the function of this equation is this one. So viscosity for the solid plus liquid mixture can be approximated as viscosity for the liquid phase. So basically, when you have this kind of solid liquid mixture together as an overall slag, and you know the composition of liquid phase, and then you can calculate the viscosity of liquid phase. So that's the component here. Viscosity for the liquid phase times 1 minus solid fraction. And in the original equation, actually this is 1 minus solid volume fraction, but we don't know very well about the volume for the solid phase and liquid phase in the oxide system. So if you assume that volume density of the solid and liquid slag component is more or less same, then you can convert this volume fraction as mass fraction, and which can be easily calculated in fact phase. So what we want to actually apply in this actually solid liquid mixture together, the solution. So viscosity for the solid mixture together is same as the viscosity for the liquid at the given temperature and given condition times 1 minus solid mass fraction power minus 2.5. This is the equation we can use in the solid liquid mixture condition. So now let's look at one of the calculation for this solid liquid slag together. So here I'm going to enter CaO, MgO, Al2O3, SiO2 as 40%, 10%, 15%, and 35% in weight percent. And then I'll change the temperature from 1500 degree to 1400 degree every 10 degree. Then we'll see that up to the certain temperature, it will be liquid state only. And then below that temperature, we'll have the liquid plus solid slag together. Okay. And then after calculation, I want to extract the information for the liquid composition, the slag of the liquid slag composition, and also information about liquid mass fraction. So because I'm using 100 actually the gram as input, so if you get the amount of the liquid slag, that it means 100 minus that liquid amount will be solid amount, solid actually the weight percent, and so we can get actually the solid fraction, and then we can use this information into the Einstein-Roscoe equation. Once you get those kinds of the liquid slag information, the composition of liquid slag, you can enter that into the viscosity module like this with the temperature, and then you can get the viscosity only for the liquid slag, and then we can equate this one later in the Excel file by using the Einstein-Roscoe equation to get the viscosity for the solid liquid slag. So let's try this one by using the fact phase. So let's first open your Achille program. So let's go back to the Achille program input like this. So I already set actually the input for the CaO, MgO, Al2O3, SiO2 with the certain composition, 40% of CaO, 10%, and 15% and 35% of SiO2. And the unit I'm using as a gram and the temperature, as you can see. And then the database selection, I'm using only FT oxide database in this case. Okay. Once you do that, let's go to the next. Okay, so and then you probably have the nothing actually selected here, and you go select all the solution page and all the solid page. So and then we want to do the calculation from 1500 degree to 1400 degree every 10 degree like this. Okay, so once you enter all this one, we're going to do the calculation. Okay, so this is the calculated result from the 1500 degrees Celsius to the 1400 degrees Celsius. As you see, 1500 degree we have slag, and by the way, there's some bond fraction information because we still actually activate this the display for the bond fraction. If you don't like, you can go back again and the parameter, you can just eliminate this one, say okay, and then you can run the calculation again. Then you have the much simpler actually the display. So I have 100 gram of the slag at 1500 degree, 1400 degree, 1490, 1480, 1470, 1460, 1450, and etc. until you reach to this one. So 1420, for example, you see that there's the 93 gram of the slag, and then there's 5 gram of the melilite, and and then also the slag composition is changed from its original composition. Okay, and similarly, if you go to 1400 degree, we have now only 46% of the slag and then 53% of the melilite existing. It's okay. So now what we have to do is we have to extract the information for the viscosity calculation. The first information we have to extract is the composition of the slag, liquid slag at each temperature, and then also the amount of the solid phase or the amount of the liquid phase. Yeah, that's what we have to do. So what I want to do is go output and then save or print as, because I want to extract this information in Excel. So you can select Excel spreadsheet and then spreadsheet setup. So we have to select what kind of the information we want to take it out from this calculation. So here you see some of the system information, and this is the more page actually the information. Okay. So for example, if you click on this one, you can see that what kind of option you can use. Okay, page number, alpha, if you have the variable, and then temperature, pressure, and etc. So the only information we need in this case is temperature, and then the other one you don't need it, so you can eliminate in this way. You can or increase more to get more information. So in this calculation, I want to take only temperature out, and then now you can take out the property of the phase you actually have in the calculation. So I want to take out the composition in terms of the weight percent or mole percent, and then also I want to take out information about the amount of the slag. Okay, so go here, and then now you can see that there's the gram and then some other things. So for example, I want to take out the gram. Okay, so good. And then you can say, okay, I want to take out also weight percent. Okay, these two information. Okay, and then go select. So what kind of gram, what kind of weight percent you want to take it out. Okay, so gram, for example, I mean, there's the many different way in this case. So if you go here, there's the all compound information first, solid compound, and then you can have now FT slag solution and spinel solution, and then all kinds of other solution. So for example, if I take this 1, 2, 3, 4, this information, Al2O3 in the slag, CaO and SiO2 and MgO in the slag. So this means I'm taking the, as you can see, what I said is gram of this component and weight percent of this component. Both of them is taken out. So it means I want to take out weight percent of Al2O3 in the slag, and also I want to take out what's the actual gram of Al2O3 as a slag component. So if I sum up all this one together, that will be amount of the total slag, liquid slag. Okay, and then I want to also see the each weight percent of this one. So this is good because and then sometimes if you want to actually take out actual gram of overall slag, overall liquid slag, then you can go down here, and at the end here, you can see that there's the solution FT slag. So this is gram of the total slag, total liquid slag. So let's see what's the difference, and then it's okay. Say okay, and then you can say okay button here. Then now all the setup is done, and then if you click OK, now it will generate Excel file for you. Okay, so then if you say OK, then it will ask you, okay, what kind of the Achille file name you want to use. So if you don't like this name, you can change it. And then even you can actually assign this information to specific seat number or seat name if you like. And then if you click just simply save, then it will save, but you cannot see the result. You have to go back physically to this directory and then open it again and then to see the information. But if you open, then it will actually save and open for you automatically. So I prefer this option, open. So now the Excel file is generated here by extracting the information from FactSage. So let's look at one by one what kind of information we have here. I'm sorry, I'll just make this one a little bit small. Okay, so here the temperature. Okay, at each temperature, what's the gram of the Al2O3 and what's the gram of SiO2 in the slag, what's the gram of the CaO, what's the gram of MgO in the slag. And even though we choose the only slag number 1, slag number 2 information is automatically copied because of the this is by default in FactSage, so you don't have to worry about it. And if you don't like it, you can simply delete it. Okay, and then weight percent. So because we are using 100 gram as initial, so the gram of the liquid phase and gram of the weight percent of Al2O3 in the liquid phase is same if there's the only slag existing, only liquid slag is existing. Okay, so that's why these two information is same. And now if you look at this one, when you have the solid slag start forming, then your gram of Al2O3 and the weight percent of Al2O3 should be also different, of course. This is correct. And then now if you go further, so slag number 1, slag number 2, I'll just remove it because we don't need this information. Slag number 2 information, I'll just simply delete it. And then you can see also the amount of liquid slag, total gram of the liquid slag. Okay, so up to this temperature is the 100%, and then below you can see actually the decreasing of the amount of the liquid slag by forming solid slag, of course. And then this is the gram of the number 2. Number 2 is all 0, so it's okay. And then also now after that, because even though we want to take only gram, but we set actually gram and the weight percent in the calculation. So you can see even the weight percent of the FT oxide slag solution. And of course, we cannot define even weight percent of this one. So it's all uncalculated, okay, not calculated. Okay, so we can remove all this one because we don't need this information. Delete. Okay, so now what we need for the Einstein-Roscoe equation is we need the viscosity of liquid phase. Okay, this is one of the information we're going to generate by using the FactSage viscosity module. And the next one is 1 minus solid fraction. Okay, so this one, we're going to take it here. So viscosity for the liquid, first let's look at the 1 minus solid fraction. It means this is same as liquid fraction. 1 minus solid fraction is same as liquid fraction. Yeah. So we can simply say that, okay, liquid fraction is same as weight percent of the liquid if you consider the density of solid and liquid is same. Okay. So then we can simply take this divided by 100. Okay, so this is liquid fraction or 1 minus solid fraction. Okay, so when you do this one, you have to be careful not to use the mole fraction, because mole fraction is really number of mole of the phase is really depending on the formula, the chemical formula you define. So if you define Al2O3, one more is Al2O3, And you can also define AlO1.5 as your phase. Then this is the 2 moles of AlO1.5 is actually same as the 1 mole of Al2O3. So mole, the amount of the moles is really depending on how you define your chemical formula of the your phase. And that's actually quite different from the weight fraction or weight percent. If you consider density of solid and liquid is same, the best way to take actually the fraction is the weight percent. Okay. Okay, good. And then now eventually we're going to calculate this one, viscosity of solid plus liquid slag together. Yeah. So this will be, as we see, this one times this one power minus 2.5. That was the Einstein-Roscoe equation. So I'll just set up here already for that formula. Okay. And then I'll try to now enter this viscosity for the slag. Okay. So for the viscosity for the slag, we have to enter the composition of the liquid phase. And that composition is basically this composition. Okay. So this is the composition. And then the temperature is this one. So we'll enter this information in the fact phase. So let's look at viscosity module now. So now we'll open the viscosity module and then clear all. So you know this is the viscosity module, and first you have to change your unit. Okay, unit viscosity. So in the mass as a gram. Okay, yes. Okay, and then also the unit for the viscosity. You can choose whatever you like, but I typically like a poage. Okay, so 10 poage is 1 Pascal second. Yeah, so poage. Okay, this is more engineering unit people used people used in the metallurgical actual industry. Poage. Okay, and then the database, collapse database or melt database. In our case, you have to select melt database because this is the liquid slag. Okay, that's good. And now we have to take then information from FactSage here. So I'm gonna take this weight, so temperature first. So I Control C. You can take Control C. You can copy it, and then you can go to your viscosity module, and then where's the temperature? So if you move this one to the right side, you can see the temperature here. Okay, so temperature, I Control V. Okay, Control C, Control V is working. And then I'll take this Al2O3 weight percent composition of the slag, Control C, and then you can go all the way Al2O3. That's good. And gram in this case, but I mean basically we want to enter the weight percent here in this case. And then SiO2, Control C, and then you go back again here, SiO2, and then you have CaO, then you have CaO, and then you have MgO, okay, and you have MgO. Okay, so everything's done, and now what you have to do is simply calculate. Then FactSage will take this information and then open the Eclipse and enter this information and then calculate what's the bond fraction. From the bond fraction, it will calculate structural actually unit for the viscosity module, and then it actually enter to the viscosity formula we set up in the viscosity model, and then it will calculate the viscosity for slag by slag, so the composition by composition. Okay, and because this actually the calculation is this viscosity model is the coded by using so-called FactSage macro processing, so it's sometimes little bit actually slow, but if you're actually patient enough, you can get all the information in time. Okay, so now we have done about 4 or 5 calculations here, and then if you go to the left side, you can probably see some of the result is ongoing result. It takes time, so let's wait. So far, I mean, if you look at the bar below, we have done about 56. So about half of them is done. Okay, let's take a couple of the the minute and then see the result. By the way, this actually the module. You can do both oxide and oxyfluoride system together. Yeah? And one of the most recent addition of the element here is the lithium oxide. Okay, and so you can actually enjoy the viscosity calculation. And then we believe that this viscosity model is the very accurate and very predictive. And so if you have any actual composition within the range here, you can get the quite reasonable actually result all the time. Okay. So now everything is done. So let's go back and then let's look at the result. Okay, so this is the result for the viscosity. So I'm copying this one again, Control C. And then I'll go to my Excel file and then enter it here, Control V. Okay, so let's look at the viscosity. Okay, so let's just make it a little bit bigger so we cannot see it there. Let me take it. So here you go. So let's look at the viscosity by viscosity. So this is the viscosity for the liquid slag, okay, with the temperature. So it of course increasing with the decreasing of the temperature, as you can see here. But the viscosity calculated for the solid and liquid together is quite different when you actually see the change of the solid fraction. So here, when it is about 93% of the liquid fraction, that means about 7% or 6.5% of solid is existing, then the difference between the liquid and solid is reasonably small. Liquid only and liquid plus solid together. So there's only about, let's say, 10% increase. Okay, but now when actually the solid fraction is increased to about 27%, now the viscosity is and viscosity for the solid and liquid together is about 2 times higher than actually the original liquid only. Okay, and then if you go to the about 55%, 54% of the solid fraction, then it's crazy because you can see it's more than about 7 times actually of the increasement. Okay, so this show you that when you have the solid start forming in the liquid, your viscosity for the solid liquid mixture is increasing drastically. So you're going to have some problem for the flow of the actually it's more difficult to actually flowing out your slag from the furnace, for example. And this actually the Einstein-Roscoe equation. However, you have to remember that this Einstein-Roscoe equation was developed considering the solid morphology is the spherical shape. Okay, but in the many cases, the morphology of the solid phase forming in the slag is not spherical shape. You can have some dendritic shape. Sometimes you have needle shape. Sometimes. So Einstein-Roscoe equation may not be the general solution for you. And also Einstein-Roscoe equation was developed for the solid, which is up to about 15%. And so when you go to the high amount of solid fraction, even though the shape is spherical, the solid shape is the spherical shape, the equation may not valid at the high solid actual fraction region. Okay, so you have to know the limitation of the Einstein-Roscoe equation. But when you have in general, from my experience, when you have in general the solid fraction up to about 10-20%, you can still use the Einstein-Roscoe equation to reasonably estimate your viscosity. Okay, and there's the many other kinds of the modification of Einstein-Roscoe equation available in the literature. So if you like, you can collect them and then read them again too. So anyway, so in this example, I just show you how to combine the liquid viscosity to calculate solid liquid mixture slag viscosity by using the Einstein-Roscoe equation. Okay, so if you have any question, you can always contact me too. Thank you very much.